This video is brought to you by FTC Team Turtle Tech and FLL Team 2x4. One of the most useful sensors in FLL is the ultrasonic sensor, which allows you to see your distance away from something. The problem is, most programs that use the ultrasonic sensor don't use the gyro, and if they get knocked off, they can see something wrong and end up completely different from where you want them to be. A gyro straight drive program for the spikePrime. And the first thing we're going to do is open a new word block project. The first block we're going to add in, because it already has the one program starts block, set yaw angle to 0. This block's important because it resets the gyro's position, whatever it is, and it makes that 0. And that's going to be useful in our code. We're going to go to movement, grab a set movement motors. And on my robot, they are A and F. Never mind. That's better. And then we're going to need a repeat until block. And in the little Boolean thing, you can put whatever you want. Personally, I'm going to make this with the ultrasonic sensor so that it stops when it is within 12 inches of the wall. My ultrasonic sensor is D. In this, you can put how many rotations you want it to do, how long you want it to run for if you use the timer. Whatever you want to do, do it. You can make it go until it sees a black line, anything. Now, in this block, we're going to get a set, we're going to need to make some variables. We're going to make a variable motor power and correction, and we are going to set motor power to however fast you want the robot to drive. For this, I usually do something like 15 because we don't want it to go too fast because the gyro can't keep up. Piece of advice: do not make it go to 100 speed because it will not be able to correct itself at all, and it will just drive in a straight line the entire time. So don't do 100. You can do 80 though. That's fine. Next, we're going to set correction to 0 minus the yaw angle. This just sets the correction to whatever the robot sees, which is, or whatever the gyro sensor is reading, which is 0 minus which is the yaw angle, and we just subtract that from 0. Next, we need to get more movement, which I already did, and we're going to start moving at 50% speed, only that's not what we're going to do. We're going to start it moving at plus speed and minus speed, motor power plus correction, and motor power minus correction. And then the very last thing, and most important thing, stop moving, because otherwise it will just drive forever. And that's not necessarily what we want to do. So, the way this entire program works, we start by setting the yaw angle to 0 so that wherever the robot is, it will drive straight to that. Because if we don't, then it might be driving completely different from where we want it to go. Then we set the movement motors to whatever your movement motors are on your robot. This is just me for mine. Then we make it gyro follow until a certain instance is reached. In my case, it's with the ultrasonic, but you can do this until it sees anything, whatever you want, for time, rotations, anything. And then we set the motor power to 15. That just makes the robot drive at 15 speed the entire time. Then we set correction to 0 minus the yaw angle. And then we start moving at motor power plus correction and motor power minus correction. Basically, 15 plus whatever the correction is and 15 minus whatever the correction is. And here's the actual code in
heaven. He is far from heaven, that's for sure.
I have to come all down again.
Is it like gelled or is it just
No,
wet?
it's just water.
Okay.
Yeah, it's
Please subscribe and tell everyone you know about me.